Okay, there we go.
All right, so I'm gonna let you, as per the email today, mostly just gonna let you work on the web work that you still need to finish, and then the new one that's opening up today, and I think it's due next Thursday. It shouldn't be too, it'll be a little more challenging just because it's substitution, but some of the ones on there are super quick. So it won't all be really intense. Substitution's tricky because if you see the right thing, it usually is pretty easy, but if you don't, you can struggle. So let me just give you a few substitution tips. And then on Monday, we are starting a new topic. We're gonna start really, I said Calc 2 starts today, like on Wednesday, but really Calc 2 starts on Monday when we start talking about integration by parts. And that's where some art and science play a role. But substitution tips. So my tips are this. If you've got some integral that you want to do, and there are parentheses in there. This is like the most basic meta. Okay, I think that's right. Parentheses. A good first guess for you is what's inside those parentheses, right? And this might be obvious, but it might not, and I just want to say all the things that I like to tell folks about substitution. It's possible that unless that thing in there is just an x. If the thing in there is just an x, when you let u equal x, you have just rewritten the problem and gotten nowhere. You've just converted it to a new variable. So that's not something you ever really want to do. But if there's something more involved in that, multiples of x, polynomials, trig functions, let u be the thing inside there. So that's tip one. Tip two is for fractions. So when you have an integral, and inside here you've got a fraction. So we've got a numerator and a denominator. Almost always, now these rules will have exceptions, and there might be a few exceptions in the web work, and there might be in some things that I give you to do, but these are always good first passes on substitution. So in the denominator, let's say the denominator has parentheses in it. Well, you've already got rule one, so that kind of tells you what to do. So let's just note if the denominator looks like some parenthetical thing, or it's a function of something. Now this f, when I say this might be a little misleading. It could, be something like sine, cosine, tangent, natural log. If it looks like that, first good thing to try is what's inside here, unless it's x. Never let u equal x. So parentheses in the denominator say that my u is probably the thing in the bottom. So let me give you an example for this, actually. So let's say I had something like, and down here I've got, let me be a little craftier. And then I've got, so parentheses also can be represented by radicals, and that's a really important tip to keep in mind. So parentheses, but keep in mind that really a radical acts like a parenthesis. So no matter what that root is, it's essentially a parenthesis. Parentheses implied here. Sometimes it'll be written like that. So when I see this one, I've got a fraction, I see parentheses in the bottom. My first guess is let u equal 1/2 x squared plus 3x. Test my du, looks beautiful, but I set it up to look beautiful, and I see that this thing is ready to roll. You want to see some facsimile, something, maybe, some kind of pattern that looks just like your du. And this needs to occur in the numerator. So just a little note here, du is always in the denominator, in the numerator. Never otherwise. So you'll never have an integral that looks like that. That'd just be weird, right? It looks really weird to me. It may or may not look as strange to you, having not done this quite as long. Okay, so then what else? Let's take a look at this. What if I have x plus 3 over 1/2 x squared plus 3x? No parentheses, no implied parentheses. When you have a fraction and there's no parentheses or implied ones, u is probably the denominator. And then there's one more case after this. So fractions, we've got this. If, this is case A, here, case B, here, if we have integral and I have a fraction and there's no parentheses in the bottom. I have two options actually. Let's go down each of the routes. So first option is it's integral du over u form. In other words, it's a natural log of u form. And in that case, I'm going to let u be the entire denominator. So here I'm going to let u equal the entire denominator. You know, maybe that's why I haven't been spelling them. So let u be that whole denominator. There's one other case, and even in my class, we didn't really talk about this. So, and probably very few folks in Calc 1 did, or it's even been a long time. So let's look at this. Here I'm going to let u equal the whole denominator. And you can see that this is going to be really gorgeous. I've just got x plus 3 dx, and that's exactly what I've got here. So this is a beautiful setup. But what if this integral looked like this? Anybody know what's up with that one?
We could use a natural log.
Well, let's try. Let's try. So cool. So it looks like this first case, right? I got fraction. There's no parentheses. So we could let u equal x squared plus 1. And du would be 2x dx. But then when I play this, so first off, warning sign. All the variables that show up in du, all the expressions that show up in your du, need to be here up to a multiple. So Lou, right off the bat, I don't see an x in there and I can't toss that x in. So that lets me know that this is not the way to go. But let's just double check here. So dx, I solve for that using my method like this. And then I do that substitution here. Let's see, what would this become? So I wouldn't write this down because this isn't going to go well. So I've got 1 over u, and then dx is 2u over, du over 2x. What's the problem here? What's befouled?
The u.
The u's okay.
Because you can cancel out though, right?
Explain more what you mean by that.
Because you got a u in the denominator and the numerator.
Okay, so this doesn't count. This is actually just a little chunk of notation, and we don't get to use
like
that
a
u.
constant?
It's in some ways. It's actually that, remember when we had the sum, it's actually what this delta x becomes. So it's actually kind of part of the notation. It's more like, here's the capital at the beginning of the sentence, and the du is the period on the sentence. It's probably a better way to think of it. Tell me what's wrong here? Somebody.
The x.
The x. When you do a u substitution, if you get to this stage and there's a mix of u and whatever your original variable was, you picked wrong. You picked the wrong thing. There's not many choices here. I know I don't want to let u equal x, unless I get my jollies by rewriting integrals as u, and I might. I don't, but you might. So where do we go? Well, substitution isn't going to work on this integral. Yeah, Kidra.
Isn't it an inverse of one of the trig functions?
Oh, Kidra, yes. Yes. This is table time. This is get out the integral table and look for something that looks like this. Now, when you go to your integral table, you will find something. So this one, sub won't work. Consult a table. And there's no shame in that, because that's really all you can do, or you memorize some result from the table, which Kendra did, which is just so awesome. But I look at my table and I see something like this. That du could be off to the side or on top. That is an arctangent. So that is 1 over a arctan of u over a plus c. And from there, now I can actually do this integral. Laying this template on top. So check this out. Let's just finish this up. And this is pretty much the extent of what I have to tell you today. So the rest of it will just be me consulting with you, and I'm going to walk around and help, and we'll probably have some group discussions over problem sets. But lay this template over the problem. What is a squared going to have to equal? Oh, well, first off, note that this form right here is also this form. So we can just write it like that. So what is a for us? If I lay this template over my problem that I have. 1, yeah, it's just 1. So laying this over the top, we get a equals 1 for our problem. And that means I'm pretty much done, right? I can just rip this through. This becomes, with a equals 1, integral dx over x squared plus 1 equals 1 over 1 arctan of x plus c, and you got that beautiful result. So fractions, 3 routes. Parenthetical, use the thing inside. No parentheses, use the whole damn denominator. Or it's a table, and it's probably an arctrig function, very likely. Let me give you one more really quick here. Let's say I had this. So let's play the game. And until you start to recognize this is a great algorithm. This is an algorithm for success. So going by my algorithm, first thing I would try is let u equal the stuff inside the parentheses. And du is negative 2x dx, barf. I would need an x. There's no x floating up by dx to make this work. So this is, nope. I could let u be the whole denominator. Let me show you that atrocity really quick. So if I did this, using the chain rule, this shit doesn't appear in the problem. Like, once I let u be this whole denominator, I've got that counted for. I don't see a lot of other variables floating around. So that lets me know that this is befouled. A bad choice. There's no good choice. So I go to the table, I find this form in the table. Anybody remember? Oh yeah. Nice. Arc sine. So that is the arc sine formula. And a would equal 1. It's just good old arc sine of x is my final answer here. That's all the tips I have for you today. There will be more discussion. A good job showing up today, by the way. These are always great days to just knock things out. I think we do this a lot, don't we, in my class? Do we do this a lot? Yeah, so this is like a really common Friday activity. Let's just make your lives better. Thanks, friends. I'm going to stop recording right now. But I am available for consultation. Like I said, there should be a new web work that's up. If